Hello, good morning, good evening, good afternoon, and thank you for joining our second episode of this training series in spring of 2024. Today we talk about how to tame your graph with Liquibase for Neo4j, and our trainer team has shrunk, unfortunately, due to a personal emergency to one, down to Florent Biville, but I'm sure this will not be any you know any problem. I'm sure we will manage it as such as well. All the best to Marwan for him though. So thank you for joining, Florent, and how are you doing today?
Yeah, I'm good. Thanks for having me. Looking forward to running this workshop with everyone.
Cool. Yeah, thank you. So the workshop is taking place right now. So just a couple of household items before we dive in properly. I will say that this workshop is recorded, so we will share the video with you all afterwards. So if you're wondering, something was too quick maybe, or another thing you need to look into again, then definitely you'll get the recording later this week, as well as the slides that Florent we go through. We also share that with you, so you can have a look at those in more detail and in your own time as well. So don't worry about this. If you have any questions during the sessions or any feedback, any comments, then please use the Q&A function. I will have a look for your questions. My colleague Alison will also be in chat and around for some Q&A, so she'll support us as well. So if anything is unclear, we'll try to get it done. But again, if you have been around on the intro session last week, and if not, don't worry. But it's all live, and some of these problems could be very individual, and it can be very hard to help everybody on the spot. So if you are struggling with something, please, maybe the video is a good thing to follow through, and then check it out afterwards in a bit more of a comfortable, quiet time. And if you then still have questions, you can always reach out to us on the Discord server and also on our community forum for questions and for comments. So it's hard to get everything sorted out maybe in a live session, because obviously we try to get through the content as well. So I hope that clears it out. I've sent you a link with some instructions that Florent created. So to prepare for this workshop, I think they went out yesterday as well, and just as a warm up for this show, and I put it in chat as well. So if you have the time, as soon as possible, please follow through there. I think we will go through quickly. To get there together, but if you if you are struggling with some of these, then it might be hard to get you all to speed and to the same starting point. So hopefully you prepared a little bit in advance. I think that's it. I'm good fun to all of us. I think should be a good and interesting session, and I'm looking forward to it. And I'll pass it on to you, Florent.
Thank you. Perfect. So thanks everyone for joining. As Alexander said, feel free to ask any questions at any time. We'll do my best to monitor those or react as quickly as I can. And yeah, let's dive right into it and learn more about what Liquibase can do for you and how Neo4j Liquibase work together. So as Alexander said, unfortunately, Marwan cannot join. He's been at Neo4j for a couple of years now. He's helped me with a workshop. We worked together in the community before as well, in the Neo4j community. So yeah, it's a pity, but his help already with the workshop, so I'm already grateful thanks to him. And yeah, this emergency will be solved soon. So no worries. And what we're going to do today is basically talk about Liquibase in general, like, what's the purpose of Liquibase, how does it work, what's the minimum mental model you must have before actually using it. Then we'll talk about the specificities of Neo4j as a database, especially when you consider using a tool like Liquibase. And finally, we'll, get most of our time spent on actually trying the integration, Neo4j integration of with Liquibase. But yeah, we'll need to get, first understand conceptually how everything works, how everything is tied together before diving straight away. So that's why I wanted to take a little time there. And as for myself, I've been at Neo4j for 3 years and a half almost at this point. I'm currently in the connectors team, trying, to help people connect Neo4j to their whole information system, make it better, to ingest data, export, etc. And let's talk about Liquibase first. There is always this struggle when I do a Liquibase Neo4j talk. Some people are familiar with Liquibase, some people are familiar with Neo4j, sometimes both of it, sometimes none of it. So I will try to give the best summary for both sections, and hopefully wherever you are on the spectrum, it will make sense. And of course, remember, you have Q&A questions, so shoot them anytime. I will do my best to answer. And so Liquibase, just a quick history lesson. There's been this very influential book, that might have been a bit forgotten nowadays, but which has been called Refactoring Databases. And it's basically a description, a catalog of some sort of patterns you can use to make sure you smoothly migrate your databases alongside your application, right? So and remember, that's almost 20 years ago, right? So at that period of time, it was quite revolutionary because, database management had been quite process heavy and quite difficult to manage. You have usually lots of bureaucracy involved, and, it was not as easy as agile development as you know it for application. And so basically this book presented a bunch of ideas to help bridge that gap, like why would application evolve so quickly and database so slowly? And one person called Nathan Voxland read that book and immediately got the idea, okay, I should implement that and make this available as an open source library. And that person was Nathan Voxland, and that's how Liquibase was born, more or less at the same time as this book was published. And one of the core principles of Liquibase is, it's declarative first, to declare what you want, not necessarily how it's supposed to be implemented. It's portable across databases, so historically across relational databases. Remember, we're in 2006 initially. And if you look nowadays at the landscape, it supports actually far more than relational databases. You have 60 plus supported databases, including NoSQL ones, obviously, like Neo4j and others. And if you're interested in having a more, product overview of Liquibase as a whole and the Neo4j extension, there will be a presentation towards the end of March. So you will have the slides and you will be able to have the link as well to join that specific webinar. But let's dive into now the technical concept of Liquibase first, which are also useful in the Neo4j context. At the very center, you have what's called a change. And that's it. That's the smallest possible concept you can have, and it encompasses so many different kind of migrations. So a change can be as simple as a SQL query, or in our case, Cypher query in the Neo4j case. It can be something much more complex, create table, or maybe extract those columns into a proper table. Or if we talk about Neo4j, for instance, we have a few graph refactorings, like extract this node property and make it into a standalone node, and maybe link it from the source it was extracting from to this new extracted node, etc., etc. So that's, in essence, a change. And changes are part of what's called a change set. So change set have at least one change. You can have several ones. You declare the author name and the ID, and that forms the identity of a change set, which must be unique across your changelog. And your changelog is the single entry point of Liquibase execution for most commands. So for most commands, you will want to say, here is a description of the changes I have or I want to run. These can be described, so usually in a local file, in XML, JSON, YAML, or SQL. You have also other formats, because as many things in Liquibase, it's extensible. You can write plugins to support other kinds of format. And you can even have an XML changelog that includes JSON changelog, which includes maybe a YAML changelog. Not sure that's very common to mix and match so many different kinds, but at least, including SQL change logs have happened quite often because it's a more compact format, even though not all changes are available there. But yeah, you have a single entry point of changelog, which may include other sub-changelogs. Those changelogs will include change sets, and those change sets define changes. And that's basically the three concepts you need to keep in mind when you're using Liquibase. That's about it. Of course, we'll talk about specific changes because change in itself is not enough. You have operations to perform in mind, and so you will have to look up the right change for that to make it happen. And so that's the concept, right? That's the mental model you have. But what about execution? What if I want to? So those are the concepts I manipulate when I'm running Liquibase. But how does it run? And so you have first and foremost an executor. So what we're going to use throughout the workshop is the CLI because it's just the most universal option. Because the other integrations I'm listing here, and there are far more than that, you can check the liquibase.com website, you will see more. The rest of the options there are running on the Java virtual machine, so that's not as universal as using the CLI and targeting and running it anywhere. But yeah, you've got great number of options. Whatever is your case is, you can use Liquibase core APIs in Java. You can use the Spring integration, the Jakarta Enterprise Edition integration. You can use it in your build with Maven Gradle plugins. Basically the sky is the limit. You have many different options, but again, because CLI is so universal, we'll basically use that one. So you have an executor, and usually you have a few commands available. So let's say run, which is not called run but update, which will execute, go through the single change log, parse the changes that needs to happen. And what the executor will do then is, okay, for each change set, I will open a new transaction. I will translate those changes into actual queries to run and execute them. And then what happens is that the database I've targeted, because you also need to specify a database, right? You need to migrate data somewhere, and that somewhere is specified through the database, will store the history so you don't repeat what has already run. So that's more or less the workflow. And one important thing to note, there is this logs-on, maybe you might see on the slide. So these logs-on mean that the executor makes sure no other Liquibase executor is running against the database at the same moment, because you don't want basically Liquibase executors working on each other's feet, so to say. So there is also this lock mechanism that happens first, and once the lock is acquired, sure enough, go through the change logs that have been given to the command, parse the changes, run the queries in transactions, and store it in history. So that's, in a nutshell, what happens. As I said, changelog is the main entry point of most commands, but not all of them. For instance, if you look at the history command that's listed there, for the history command, you just need access to the database. You just need to understand what history is stored there. So you don't need any description of local changes you might want to run because you're not interested in that aspect. But if you look at dry run, tag, rollback, etc., then you will need a changelog, as you will see again in the exercises that are coming. And usually it's a local file. Actually, the abstraction is a bit more powerful than that. You could potentially imagine having changelog over the network and have it resolved like that. But here in the workshop, we keep things simple, and most of the time you will deal with local files when you specify your changelog, and that's how we're gonna pass it to the executor. Then, as I said, the executor for each change set, by default, and I'm not going to go too much into details, but by default, will open a new transaction for each change set. And because it's stored in history, it will run it only once, so it's incremental. Once a change set has been run, it will be stored in history in the database, and it will not run again. And by default also, you're not allowed to change a change set after it's been persisted. So it's immutable by default. And how? Well, not only you store history, but for each change set, you will store what's called a checksum. So some kind of a fingerprint, so to say, of the change set. So if anything changes, then the next execution, Liquibase will complain, say, hey, you modified the change set, that's not supposed to happen, so I'm gonna stop there. So remember those defaults. Each change set lives in its own transaction. Immutable, so immutable is not allowed to change. Incremental runs only once by default. So that's really all you need to know at the mental model level for understanding Liquibase concepts and execution workflow. Now let's talk about Neo4j a little bit and how it is specific in that regard. Because Liquibase, as I told you initially, historically focuses on relational databases, but relational databases, as you probably know, are a bit different from graph databases, right? And Liquibase main focus is on structural changes, right? Like if I take a relational database, if I want to create a table, if I want to add a column, or change a column type, or rename a column, or add a foreign key, or define a primary key, all I'm describing here, it's not about data, it's about structure. It's about the structure of the data. And that's the biggest area of interest for Liquibase. It's not so much about loading data into the database. This is not, as Nathan told me once, and it kind of resonated with me, like Liquibase is not an ETL tool. It's not about importing data from one place to your database. That's not what it is about. That doesn't mean that it cannot do it. It can actually load data, and we will do it in the workshop when that data is needed for downstream applications to work. That's, I don't know, let's say you have an inventory, you will probably need a few categories to exist in the database for the application to work. This kind of what I call seed data or reference data, sure, Liquibase can manage it, but for regular data, application-generated data, Liquibase is not going to create that for you. That's not the role of Liquibase. It's really about structure and structural changes. And so, yeah, if I talk about relational database, it is quite easy in that universe, right? There is structure by itself. It's called, the language you use to manipulate it is called DDL, or data definition language. So you will have to create a table before you can, insert data into it or update data. A table has a fixed structure. You have a fixed set of columns. You have names, types, nullability, references to other tables. You need to declare all of that beforehand before you're able to insert data. And just to take a small fun example I ran into when I was, trying some JDBC experiments. So JDBC is a standard for database connectivity with a programming language called Java. And one fun thing, if you run the query that I have on the slide, and you say select name and height from the table persons, limit 0. So limit 0 means I'm going to have 0 rows. So I'm not going to have any data returned by that query, right? But JDBC has another API, which is give me the metadata of the result for that query. And if you ask for the metadata, well, in the relational database world, you will have it, because name and height are columns of persons, so we know the types, the nullability, etc., etc. So you will get something. However, if you look at Neo4j and do the equivalent, so in that case, it's not going to be SQL like before, it's going to be Cypher. If you do something like match nodes with the label person and return me the name and height attribute of those nodes, limit 0. As for SQL, obviously, you're not going to have any results. But if you ask for metadata, well, then, you're not going to have any, because there is no name attributes that is intrinsically linked to a person label, right? Or same for height. You might have defined constraints, but there is no automatic way to get metadata. You will have to implement something to look at constraints if they exist. But if you don't have any constraints, name can exist on nodes with label person, might not exist, or might be of different types. One person node might have a name type of string. The other type can be integer, depending on the nodes. It can be very, very different types across nodes of the same label. So there is no schema predefinition. And if you want to insert data into Neo4j, you don't have any equivalent of create table, etc., etc. You don't have to declare any structure. You just insert data, and then once data is there, then you can start to infer a schema from it. So that's like a very strong conceptual difference between the two. And so just to hammer on my point, once you've got structure in the relational world, then you can insert data, and that data must fit. Like if you have a table with a name that is a string, if you try to insert a name that is a number, that's not going to work. And in Neo4j, it's possible to emulate that with constraints. But if you don't have constraints, then it will happily accept your name as a number. That's perfectly fine. And remember, constraints are opt-in. You have to create them if you want that kind of adherence. But there is no automatic way today to infer metadata and to infer structure. To have this inherent structure like in the relational world. And so why am I talking to you about this? Because as I said, Liquibase focuses on structure, but most importantly on structural changes. Even though you won't have much structure declaration ceremony like create table, etc. in the Neo4j world, well, Liquibase can already help you bootstrap your constraints and indices, for instance. That's a right use case for it. But more than that, it will also help you with structural changes. As I told you, I mentioned a refactoring that is available with the library, which is extract a property and make it a node, potentially connected to the node it was extracted from. So that's one example. You might want to rename labels, to rename types, to merge nodes based on some criteria, etc., etc. There are ways, without actually caring about the data, but changing its structure automatically. That's where Liquibase and Neo4j work well together. And of course, because it's Liquibase, then you can use versioning control systems like Git and have those automatically run in your CI and deploy to your environment, so that it's all about the velocity of changes for the database, to be as agile with databases as we are with applications. So that's what you get for free by being a plugin for Liquibase, and that's what we get with the Neo4j plugin for Liquibase, of course. And there is much more. But yeah, let's dive right into it. If you have any questions about this, please let me know. That's basically the concept I wanted to talk to you about before we start the exercises. So yeah, I'm all open for for questions. I will try to answer them, and please shoot them. And in the meantime, we'll finally start the workshop. So as Alex mentioned, there are a few setup instructions. We will take some time to go through that just to make sure most of you, if not all of you, are ready to run and start the workshop. If not, you can follow along and then watch the replay and try again. We'll take, I will give some time for the exercises and then we'll solve it together each time, so you're not completely lost. And those things like the Liquibase Neo4j documentation, Cypher manual, Cypher ref card are also links in the setup instructions guide, so you can also find them right there. So I'm just gonna open the document right now. You all have a link to it normally, and I believe Alex has posted it again, so you will be able to see all the instructions there and the useful links as well for the workshop. So let's start the workshop now officially. So first thing first, Liquibase is a Java tool, so it requires a Java installation. And just so a recent, it doesn't have to be bleeding edge, but hopefully you all see my terminal. But if you run something like Java -- version or just -version, if you're running all the versions, here in my case, I have Java 21. It could be even Java 8. So Java runtime environment, you don't need a development kit. You don't need the JDK. You just need a JRE, Java runtime environment. But yeah, that command should work. If that's not the case, then you want to go through the instructions to actually install Java. So those are in the documents. That's the first part, basically. I gave a link. There are different ways to install Java. If you don't have it yet, please try it. So you will see, you can click the link. I give you there are many distributions, so pick the Java distribution that you like and install a JRE. You can install a JDK if you want, but we really only need the JRE part of it. All right. So of course, if you are stuck here, please let me know. We'll take some time to actually make sure your installation works. Then you need to install Liquibase. So if you're on macOS like me, you can just run brew install Liquibase. You can also, with some instructions, you have yum install for CentOS or apt install Liquibase. Or Chocolate if you're on Windows, but really the most universal way is just to go to the link. So I can send it to the chat, or maybe at least send it to Alex, and Alex can share the link. So here we go. So the link will be shared shortly with you. Again, it's also in the setup instructions. You will see, so there is a lot of details about what's been done in this great release. You will see, so depending, so if you're on Windows or macOS, you have an installer. So you have the macOS installer or the Windows installer. On Linux, you have the archive here. So either zip or tar.gz. And you just need to uncompress it and make sure you export Liquibase to the path. All right. So if you're on Windows, you have an installer, same for macOS. And otherwise, you can extract the archive, export it to the path, at least temporarily. So you just have to write Liquibase and not the full path to it. That will be a bit more convenient because we're going to run the Liquibase command quite a lot. And as a result, you should be able to do something like this. And it should work, right? It prints a few details. We don't have to dive into it right now, but you should see something like this, like a banner, version 4.26.0, so that's important. Make sure to pick 4.26.0, which is the latest version, and that should work. If you have any trouble here, also please let me know. Again, this is in the same document, Liquibase installation, and you can pick the Windows installer, the macOS installer, or the archive, or if you fancy more, different options. You can also use Homebrew on macOS or apt install or yum install if you follow the instructions. So here I linked on the slides to apt, but you have the same for CentOS, and you can use Chocolate as well if you have it. So that's step one. And the final step before we can start is actually get the extension. By default, for now at least, Liquibase does not ship the Neo4j extension, so that's an add-on that you need to get. So in that case, what you need to do, and it's also in the document, Neo4j, it's called Neo4j plugin installation, sorry. You will need to get the latest release of the extension and grab this, the first jar in the list, Liquibase-neo4j-4.26.0.1-full.jar. You know that the full bit is important. You will need to download that. And basically what happens, so in my case, because I use Homebrew, the file tree is a bit different. So I need to go to Homebrew, Seller, Liquibase. So that's because I'm using Homebrew, but the lib folder exists in all Liquibase installations. So you will have to locate this lib folder. That is, if you've used the archive, it should be right there. And you will need to drop Liquibase neo4j. So 4.26.0.1 full.jar right there. Be wary, there is another lib folder, but that's internal lib, and we don't want to touch this. You want it to be in lib, the lib folder of Liquibase. So you will need to download the jar and put it there. And as a result, actually I will come back to where I was. Yeah, I don't need, but for the exercise it will be more useful. If you do Liquibase version again, actually, this time you will see, this line basically, you will see Liquibase Neo4j mentioned right there. That's a proof that you've set up the extension properly. And then, what you will need, so in terms of Liquibase installation, that's it. So you need a JRE as a recap. So Java -- version or Java - version needs to work. Something recent, 11, 17, 21, even 8 should probably be fine. Then you need to install Liquibase itself. So Liquibase -- version should work. You should see a beautiful banner. And once you've downloaded the extension, the Neo4j plugin jar, and put it in the lib folder, then when you do Liquibase -- version, you should see Neo4j towards the end of the list. And that's proof that your Liquibase setup is correct. Please let me know if there are any issues. But after that, then you will need a Neo4j database. I hope it's not too much of a surprise. What I recommend is to go to sandbox.neo4j.com. If you don't have an account, please create one. Otherwise, log in with your existing account. It's free of charge. Don't worry. You're not going to have any credit card info or anything like that. And in my case, I already have a recommendation sandbox. So that's the one you want. So if I show you as if I was creating a new one, you will have to scroll a little bit. So don't pick movies, but pick recommendations. That's a recommendation sandbox we're interested in. And I will, because of the zoom in, I'm used to seeing it in a particular place, but with the zooming level, I don't see it. But crime, it should be right there in the list, and I guess you can even search for it. But I already have it. That's why I cannot create two. So that's why. But if you if you don't have it, create one in the list. You should see it, and you will be able. Is there a link to the presentation? Not right away, but again, the most important link at this point is the setup instructions document. So everything that is I'm showing in the slide right now in terms of setup is also in the document. And as for the exercises, it's not on the slides. It's going to be me giving instructions. So the setup, you will see a Neo4j installation section. Option 1 is to use Neo4j Sandbox, and I think that's the easiest one. Make sure to write down the credentials. So in my case, I'm not going to delete it right away because I'm not using it. But you will see username, password, and bolt URL. That's all you need. And now that you've all seen it, I'm going to delete it because I don't want, I'm not using it for the workshop, but that's something you can do. So I will terminate it. And actually, now that it's deleted, I could actually show you recommendations. So if you want to go to Sandbox, you will see a recommendation somewhere right there. You just click on it, create, and here you go. And here you will have it. It takes a little while to spin up, and then write down the credentials. So username, password, URL, because you will need it to run with Liquibase. All right. If you want to take, the slightly harder option, you can create a local database if you want. That's what I've done, either with Neo4j Desktop or Docker, or even installing Neo4j right into your machine as well. That's another option. There is a link. It's also described in the setup document, right? There is a link to the dump file, and what you will need to do, you will need to load that dump file with Neo4j admin. And once you've done that, so you will need to stop the database, run the command that is in the document as well. So Neo4j admin database load override destination from stdin Neo4j, and then redirect the file content. So make sure to fix up the path to the file, and then it should be successful, and then start in the instance again. And you can actually run these commands as many times as you need. That will reset the database with the recommendation dataset. So in case you do any mistake during the exercises, that's one option. For Sandbox, I would advise, if you make any mistake, and because we're going to do write queries, you're going to modify the database. If you do any mistake and you feel the dataset is a bit ruined now, I would say, keep it simple, terminate the Sandbox, recreate one. That's going to be the simplest thing to do. All right, so I'm gonna, for now, I'm gonna give it a few more minutes just to make sure nobody is stuck. So remember, you need a Java runtime environment. So Java-version or --version will work. You will need Liquibase --version. So once you've got the extension as well, you should see a beautiful banner and Liquibase Neo4j listed. And finally, you should have Neo4j running. So in my case, it's running in Neo4j Desktop, but you can use Sandbox. That's just gonna work out fine as well. So in my case, and just to make sure you got the right dataset, you should have around, I believe it was like 9,100 something movies, for instance. And so I'm using, so let's have a quick look. If I match movies and count them, I believe I have around 9,125, is it? Let's see. Yes, all right. That will be, because if you pick the movies dataset, it's much smaller, there is less there is fewer information in each movie, so that's not going to work out for the exercises we want to do. All right. So yeah, in my case, I'm using Neo4j. You can actually use Neo4j desktop once you got a sandbox, right? Like if you do this, I can actually show you. I will terminate the database right after because I'm not going to use it. But if I pick recommendation again, let's go ahead and create one. Then you have this option where once it launches, should launch pretty fast. You can do open. Where is it? Is it here? Open with browser by default, but I think you can do open with workspace. And you've got also, this one. Or did something change? Yeah, that's not the one I expected, but no, okay, my bad. There was actually a Neo4j. Yeah, that's not what I wanted to do. Anyway, that's the joy of being live. You make mistakes. I think there was something
I think there's no button anymore, Flora, but you can basically copy the information and go into desktop and add a remote
Thank you.
connection, and then you
I
can.
swear I saw it before, but
yeah,
yes.
I think that has changed.
Yeah, no problem. All right. So yeah, you can indeed, if you go to Neo4j desktop, let me close this for now. You can do, add remote connection. And then indeed, as Alexander said, give it a name if you want. Give the, if you go to the details, copy the bolt URL, and then, give it the password, the username, and you will be able to use, your Neo4j desktop tooling as if it was local, and then you'll be able to run stuff. But I'm not gonna use it. It was just to show you how it can be done. And I will also terminate the sandbox because I don't need it. But yeah, I would recommend to use sandbox for now. It's much easier. All right. So moving on again, please let me know if you have any issues. Let's get started for real. So we have Liquibase, we have Neo4j. Life is good. Let's see. So in the very bottom of the setup document, there is the very last link. Give you access to two files. An XML file. It could be JSON, YAML, SQL. I decided to stick with XML. I'm a bit old school. And a CSV file. You're not going to need the CSV file right now, but you will need it soon. So make sure to go to that link, download or copy the XML content, and download the CSV because we're going to use it. And make sure they're collocated because it will just be easier. So once you have that, you should have, like me here, and I'm going to, for now, have my little thing here. So I have my XML file. So that's the boilerplate, right? You have XML schema and stuff, and we have our first change set. We'll add more things to it, but that's our very first change set. And as you can see, there is APOC in it, right? Because there is no magic, right? If APOC is installed, then of course you can use APOC in your Cypher queries. And the way you do it, you specify Neo4j, the namespace, and then Cypher, and then you can pass whichever Cypher statement you want. And all right, so that's our very first change set. And as the name suggests, so you're encouraged to give descriptive IDs, right? And author, obviously, you're all Liquibase fans by now. 5 minutes in, you're already all convinced it's great. You can put your name instead if you want. We're going to remove the constraints because we want to add different constraints, really. That's what we're interested in. So that's what we're going to do first. We have a very, very first change set. That's already done for us, right? Yeah, it's a bit of a spoiler, but this one we'll do together. And just to show you what we have currently, so if you have Sandbox, you can open in the browser or with Neo4j Desktop as a remote connection. You do the way you want. And if you do something like show constraints, if you run something like this, yeah, you should see a bunch of uniqueness constraints. So one is on the user node with user ID, movie ID, movie TMDB ID, person TBMD ID, genre name. We'll get rid of those. Basically, what we're saying with this statement is get rid of, keep those indices, so the indices on movie tagline, movie release, person name, etc. But basically delete, because the flag is true, delete all the constraints. And so to do that, well, okay, we have described what we want, but now we basically need Liquibase to actually work a little bit. So for that, we're going to be careful. First, we're going to do a dry run because we're not exactly confident. So if I just do this naively, I'm not sure what I need to do. There is this update SQL. But basically what it's going to do, it's going to show you the SQL. Remember, it's a 20-year-old project, so it has some kind of a bias towards using relational words, but translate SQL to Cypher in your head and it's going to be fine. So what it's going to do, it's going to show you the Cypher queries it would actually run, but without running them. So that's quite useful. But for that, it still needs to understand what needs to be run versus what's been in history, even though it's the first run and we don't have any history yet. So we'll need, okay, update SQL. That's what we need to do first. And if we messed up our change logs, change sets by mistake, this will also be caught at that point. So, that's quite useful. Okay, what do we need to know? It's complaining about that a changelog file is missing. Okay, great. So I will need to give a changelog file then. So changelog, let me be sure I always miss that one. Yeah, file. And I'm already in the same folder, so I will just give this changelog XML. And now I will need to give, it will probably complain about, there is no database information, so it doesn't know where to connect to understand the history of things. So now you will need URL. So in my case, I'm running locally. In your case, if you're running in Sandbox, remember the connection credentials section. Make sure to copy the right URL. And with a small twist, it needs, because it's JDBC based, it needs to start with this. It needs to start with this prefix. So you need to write JDBC Neo4j and then paste the URI from Sandbox. Or in our case, for people who run this locally, you will need this, just localhost. The port is the default one. I've not changed it, so it's still 7687. And then you will need username. In my case, it's Neo4j, and password, which is very secret, very secure. I'm showing my password to everyone, and because it's shell, it can interpret exclamation mark. So if you do this, in theory, we're live, so I might do a mistake, but in theory, Liquibase will, read the data. So first lock on the database, remember, right? No, we don't want several Liquibase running at the same time against my database. It might corrupt things, so we don't want that. It will lock on the database, read the history, compare with the changes described in changelog.xml, and determine what needs to run. And if we do that, all right, okay, we see many things. So we see the beautiful banner. We see a few internal things as well. Liquibase is very transparent, doesn't hide what's going on. So these are things that are done by the extension. We don't really care. But then the update actually starts there. And what we can see, here is our query. Nice. There is a APOC schema assert procedure that we're calling. Nice. That's what we wanted to see, right? And there is much more going on because we need to create the history as well to remember what has been changed. So not only it needs to run our change, but also remember it's run it. So it needs to have that history. And at the end, I told you about locking. At the end, it makes sure it deletes the log so that other Liquibase executions can run. But overall, I just wanted to see this. We're seeing the change we wanted to run. So that's all good. All right, so that's our first step, dry run. And so far, we've not done we've not done anything, right? We've not run, like, if I rerun the query show constraint, it's still the same, right? It's still the same as before. Nothing has changed. Nothing has touched the database. We read stuff from it, but we have not run anything. And so now, what we want to do, and that's so that's a workflow you really want to repeat all the time. Like update SQL first, make sure there is no mistake, and then run update, and hopefully you're good. And by the way, there is another command you can do, just to prove you nothing else run. If you do Liquibase history, you don't need the changelog here. And you can say no change set deploys, which makes sense. We've not done anything yet. All right, so all good. So I'm just gonna take now this.
Florent,
Yeah,
quick question. When you use Sandbox at this stage, you just replace the URI from where it says here in your terminal view localhost. You just copy in the URI that Sandbox gives you, right?
exactly. So that should be something like bolt colon. So you'll still need the JDBC colon Neo4j colon prefix, but then it's some I'm gonna write some random IP, but something like that, right? And then the right password. So that's what you need, right? You will need
and that's something you can copy and paste right from your Sandbox view
exactly,
page
yeah.
that you showed earlier. We just copy the URI, put it there, username, password. Well, username will be Neo4j, password as specified, and then you can connect from your terminal.
Absolutely. And so you have ways to not, write the password in clear text. I'm just keeping it simple for the workshop. I'm just, showing it to everyone. But yeah, there are ways to actually avoid that. I can, follow up on that if people are interested after the workshop. And so in my case, I'm running locally, as you've seen. And what I'm going to change now, so I've done my dry run. It shows me the queries it would run without running them. Now I'm actually going to run. And I will do this. Remember what we have. We have only a simple change set for now, simple query in a change set, so simple change. And if we do that, we should see, boom, running. Okay, and it told us in summary, okay, I've run one change set in total, and that's it. And so if I rerun the history command, now I should see, okay, so there was this remove constraints, dash something for some reason, author in this file that was run at this time. So localized time, as you can see. And if we actually look at the output now, show constraints is empty because we dropped all the constraints. Okay. And funnily enough, I stalled with incremental, so it's not going to rerun again. If I run that again, so I'm rerunning update, well, previously run, so it didn't run again. And if I look at history, I still have only one change set, which has run before, now it's 48 on my clock, it's still 47. And obviously there are still no constraints, not because it rerun. Oh, interesting. Oh yeah, those are the constraints of the extension. Those are not the constraints of the dataset. You can see this dash Liquibase thing. Those are a bit different. But those are not the constraints of the movie dataset, so we didn't remove them. All good. So moving on, the goal of exercise 1 was, to get familiar with these commands, but we actually want to do a little more, but, keeping it simple regarding changes. So what we want to do now, and I will, leave you to it a little bit, is to create first. So let's do step 1 first. Yeah, okay. Let's do it slowly together then. So what we're gonna do in that case, it will create another constraint, which will be, and I will go slowly. So if you want to do it yourself, you have time to do it as well. We're gonna create a node key constraint, which is a more recent constraint that's offered with Neo4j on the movie nodes and the IMDb ID attribute. So let's try. So if you're not sure, let's just sample a few movies to make sure what they look like. Just gonna limit to 5, right? And if you look, you have, I'm not sure, yeah, I can move it here. I'm not sure you can see it, but you have this IMDb ID attribute, and we're gonna make a node key constraint. Node key constraint means IMDb ID property must be present when you create movie nodes, and also it must be unique. So it's unique and existence. You have uniqueness constraints, you have existent constraints, and they have a baby that's a node key constraint or relationship key constraint. So what we want to do, we want to create a new change set. So let's just do that. And again, we're gonna run Cypher in that case. So we are now in the Neo4j namespace, and we just need to write the right syntax. So that's why I linked to the Cypher manual if you really want to do the exercise on your own. So I will do it. I will type slowly. So it's a create constraint something. And if you hear my little one shouting, sorry about that. I guess he's excited about the workshop that he's doing. So yeah, you can name your constraint as you want. So I'm just gonna do IMDb ID key, and then you must describe, right? So for what, for which patterns? In that case, it's a node. So I'm just gonna do that. And I want to make sure that movie dot so IMDb ID, so with upper I for the second I, is not key if I remember. I'm checking my notes as well, but I think that should be it. Let me also have a look. All right, so that's our second change set, right? So now we should see actually, we should see more constraints popping up. Actually, I will refine my query to exclude the Liquibase one score. We're not super interested, but so I've done that. I've saved my file, and let's do update SQL again. That's a good practice to first dry run. And the command, good news, is the same. So you will repeat mostly the same commands as before. It's mostly update SQL, history if you're not sure where you're at first, and then update. So if I do this, see, I did a mistake. Great, and it caught it for me. I'm saying, hey, attribute ID must appear on change set, and that's completely right. I completely forgot. Change set must have an ID and an author. So again, try to be descriptive when you do it. So in that case, what is it about? It's add movie IMDb ID key constraint. Maybe it's a bit too much verbose. Maybe you can find a shorter version. You do as you please, but try to be a bit descriptive. That's a moral contract of this attribute. And you need an author as well, because remember, ID and author are part of the identity of change set. So good thing I ran update SQL, and I kid you not, it's honest mistake, I forgot. It was not just for showing off the interest of update SQL. And you can see here, we can see our change sets, and as usual, insertion into history, log deletion, and whatnot. If we look at Liquibase history, we should still see there is only one change set run so far, right? Which has been 7 minutes ago. So nothing has changed there. And now I'm just gonna, as usual, replace update SQL with just update. And hopefully we should see, yeah, one change set has run, one already had run before. And in total, we have now 2 change sets that have run. So if I run history, yay. So so you can see deployment ID, which is more or less a way to group execution. So you can see they are not part of the same execution. And we had the previous one 7 minutes ago, and just now we have this one. And so if I try to, refine my query a little bit because it shows a bit too much, I'm not sure I can do, let's see, what am I interested in? Name, entity type, not so much, or we're not gonna place too much with, so I'm gonna do that, and I'm gonna filter when name not start with, if I remember well, we'll see. So I don't care about any constraint that does not start, or when not name start with, we'll see. You know what, it's live, let's do mistakes. We'll see what happens. And I think I can do something like this. We'll see. Nope. Of course, I always do the same mistake. I think it's not name start with. Yes. And yield name, What did I miss here? For some reason, it's still show. At least we show that our constraint is here, so the main goal is there, but I'm just trying to understand real quick why. Oh, because it's labels or type, of course. Yes, wrong attribute. And I'm going to take a shortcut. So the first one, because, in that case, it's single label. Yes, okay, sorry. Boom, easy. Live mistakes, and hopefully live corrections. So here we go. We have our new constraint. Great. And so now I'm going to go a bit faster because it's more or less the same idea, except there is one very important thing you need to remember when you're dealing with Neo4j. But I'm going to come back to that. What we want to do now, actually, we want to create yet another constraint, which is on the plot attribute. So if I come back to my movies that I had beforehand, you see there is this plot attribute. But remember, not key constraint means it must be unique and it must exist. I could be, I could be naughty and let you try to create the not key constraints directly, but we will run into problem. So let's have a quick, okay, let's run it here. So let's match movie, but are there any movie without any plot? So where and return how many of them there are, basically. If that's the case, then we'll need to prepare the data a little bit. In that case, we'll keep it simple. We'll just take the title and set it as a plot. In real life, you could do, fetch data from somewhere else, but... Oh, 42 movies out of 9,000. So it's not so bad, but still, if you try to create a not key constraints on plot, those 42 movies will basically cause the execution to fail, and we don't want that. So first, what we're going to do, as I said, we're going to populate this plot attribute, right? Because we basically want to make sure that we can create a not key constraint. So we'll do fixup movie plot. I'm still a Liquibase fan at that point. I hope you are too. And I will try to scroll down. Let me put a few new lines here. Yes, okay. So this time I didn't forget the ID and author. I hope you did not either. And yeah, I need to, write XML. Yeah, I picked that, so I'm the one to blame for it. All right, and then again, we're gonna do a simple change, the simplest there can be, so a Cypher query. So in that case, we want, to make sure, so we want to match movies. Same query as before, so where there is no plot, so where m.plot is null. And what we want to do in that case, we want to say that the plot should be set to the title value. And that way, we should be good to go. And you know what? I'm going to get a bit ahead of myself. I'm going to write the next one, because the goal here is not so much to fix up the movie plot, but to be able to create a not key constraint on it. And if we want to do that, it could be very tempting to say, hey, you know what? I'm just, you can write as many Cypher or any other changes within a change set, right? You don't have to write one Cypher query per change set. That being said, there is one, requirement with Neo4j transaction. You cannot mix schema operations. Schema operations can be index creation, update or deletion, constraint creation, update or deletion. And if you try to have a query that manipulates data like the one I just wrote and try to do some create constraint, in the same transaction, remember, one change set lives in its own transaction. You won't be able, basically Neo4j will complain. Again, I'm not sadistic, I'm not gonna make you see this failure, but if you tried to do basically something like this, so I'm gonna cheat a bit, I'm gonna just reuse the same, more or less the same. So it's movie plot key, require movie.plot is not key. So if you try to do that, because they are in the same change set, it means by default they are in the same transaction, it's not going to work because you're not allowed to mix data and schema operation. So what you want to do in that case, you don't have a choice. Oops, no, not what I wanted to do. We want to create a new change set. We don't really have a choice, so this time we'll actually create we'll actually create the constraint there. Create movie plot, or add, I think we said, yes, add movie plot key constraint. And then let's do again. So remember, this time it's not so much a Liquibase restriction, it's more of requirements when working with Neo4j transactions, because under the hood, that's what the extension does, right? It uses a Java driver and opens transaction and runs Cypher queries. That's what it does under the hood. So this bit will have to move. And so, I've not tested this one separately. Usually it's a good practice, to test your change set one by one. Here for, just the sake of time, I'm gonna dry run first, of course, as usual, but I will run those two directly. So I have movie plot, okay. So let's try, same dance as before, update SQL with your database URI prefixed with JDBC colon neo4j colon. Username, password, boom, we should run. And what we should see, a few things. We see our data fix-up, that's good. It's inserted into history. And part of the same, and then another change set which create a constraint. So that's good, right? It's not part of the same change set, which means you're not going to be in the same transaction. So that should hopefully just work. You can actually try, right? You will see an error. You'll see a runtime error if you try to group them in the same change set. That will tell you that you cannot mix data and schema operations. And so, okay, I feel pretty confident that it should run. And hopefully we should see 0 movie without plots at the end, and we should see a new constraint show up. So let's just do the update. And, sometimes I'm too confident, I guess. What is going on? Unable to create constraint, type node key, movie plot. Both node have the label movie and property plot director. Interesting. So that's a live demo fail. So there are movies with the same title, I guess. Oh, yes. I think I know what I didn't want to do. Sorry. That's my mistake. That's a mistake, friends. It's not a notkey constraint I wanted to do, actually, in that one. So yes, the reason was the data was not really ready for it. It's an existent constraint. My bad. And the worst part is I rehearsed this and I did the same mistake. So it should be is not null. In that case, the transaction has rollback, so it should be just fine. If we look, we should still have 42 movies. Oh, 0. Okay, in that case, well. I will have to do, the nuclear, kind of the nuclear thing. So bear with me for a couple of minutes. I will have to reset my database. Yes, that's the joy of running live. So let's do it. Let's go to this one. I'm just going to cheat, and I'm going to basically reset the database. And obviously, the Liquibase history will be reset as well, so it will try to run everything. So I'm just going to do this. Go to the right folder. So sorry, you see also live troubleshooting. Maybe it's insightful as well, even though it's not really part of the demo I wanted to do. So here we are, and I've run this before, so I can just do so I will stop the database, load the dump data, and restart Neo4j. So that should just work. So we'll wait, stop, we'll load the dump file with the recommendation dataset and start Neo4j again. And then I will be able to rerun everything, and hopefully I will double check, that I did an existent constraint and not a notkey constraint. So you can see update SQL, is not, it's great. It's a good safety net, but it's sometimes not enough because people like me sometimes fail a little bit. All right, so back. So yeah, make sure to, you have a backup system in place as well, of course, right? Or, pre-prod environments and whatnot. So workshop, here we go. So now if I do, let's do update SQL. We never know. At this point, I'm pretty pessimistic about me being able to do things in one shot. This time we'll see a lot more, obviously, because I reset the database. I'm again, by the way, just to check. I should have my 42 movies with that plot. I should have the initial constraints, etc., etc. Okay, so if I rerun, I should have history. Yeah, so if I count, which still have my 42 movies. Okay, so back to normal, and you can see there is basically all the change that we've run so far. This epoch schema assert, and then the constraint we created, and then again the plot fix up, and then hopefully we should see so the existence constraint and not a node key constraint. So my bad. All right, so now let's run. And hopefully it should work. And you can see now it runs the 4 of them because his database has been reset, which means there was no Liquibase history at all. So because Liquibase history lives alongside the data, and now we're back to back to business. All right. So that was exercise. Yes, I'm speaking French now by accident. Exercise 1 for you. So now we're familiar, right? So we've done only basic Cypher queries, which is already great, right? We can do many things already. We've got familiar with the workflow, write the change set, write the changes inside it, update SQL, check the database maybe, check the history, run update, check the history again. This kind of workflow that we need to get familiar with when we're running with Liquibase. So just to make sure, if I check history here, I should have, So in that case, as you can see, they're grouped by execution, so what's called deployment here. So they run all together. So you can see I have all my change sets right there. Oh, all right. So now let's do something a bit different, right? We've mostly been running Cypher queries, but which was available since the very first ever release of the Neo4j extension. At the very beginning, the extension was able to do just that. So let's see, what do we want to do now? What we're going to do, I told you about this whole structure versus data, right? In the relational world, structure must exist first, and then you can insert data. And structure exists regardless of whether there is data or not. That's not so true with Neo4j. With Neo4j, you have data and you infer the schema from it, the structure. But still, you can load data, right? There are scenarios when it's completely legit to load data with Liquibase, whether it's Neo4j or relational database, right? Doesn't matter. As I told you, maybe you have a set of categories as part of your catalog, and those categories must exist, otherwise the application is not going to be able to show anything, for instance. Those are the required data, what I call reference data or seed data. So let's try to get familiar with that. And actually in Liquibase, you have something called, you can actually Google that. Like if you write Liquibase load data, you should actually land right into the change. And that's where you need the CSV file I talked about earlier. So in this GitHub gist here, which is linked at the very end of the setup document, you should see, so we had the initial changelog you needed to start exercise 1, and there is the CSV right there. So you will need to download it, try to put it right next to the changelog. So that's my case here. I have changelog XML and countries CSVs. It will just be easier to configure. And what we'll do together is basically, as usual, first create a change set, right? So that's the first thing we need to do regardless. So we'll need a new change set, because by default, remember, change sets are immutable. You're not supposed to change sets after the fact. You're supposed to create new ones. It's incremental. You add stuff, you don't really come back and change. I mean, there are ways to do that, but the default behavior, and it's quite of a healthy practice, I think, is add up rather than go back and fix. So in that case, we're going to load some country data. I mean, not all countries are there, so I'm sorry if your country is not listed there. We can basically pick the countries from the data set. All right, so we load country data, but the question is, how do we do it? At some point, I will write XML in a single try without mistake. And so we want to load data. And for that, we have something that's called, well, you will be very surprised to hear. So it's not in the Neo4j namespace, it's right in the standard namespace called load data. And what you give, So it supports basically CSV, like that's the case here. What you will give a path to a file, and you will basically define your mapping with that, like what are the columns and what kind of column name, because remember, it's a 20-year-old project. It's been built relational databases initially in mind, even though now it supports a NoSQL database without the problems, as you can see. So I have this country CSV file. And then, so yeah, that's a bit of the awkward bit here. You need to say table name. There is no great way yet to say, I would love to have something like Neo4j column label, right? That would be great. That's unfortunately not super easy to do. So for now, you will have to visualize this in your head, and I have to write table name. So I'm sorry about this, but table name really means label in our case. And so in that case, we want a country label, and we'll define mapping. So yeah, I will show you the CSV file, by the way. So that's our general load data instruction. And you can see we're not doing Cypher queries or SQL queries, right? We're doing something a little more complex. And so you have a header, so the name column, and you have a bunch of countries. So now when we need to tell, okay, I've got this column in my CSV, the name. So I'm going to cheat a bit, or maybe not, it's quite easy. So you have a column of your CSV. The header is the column name in the CSV, which is name, and the type will be string. And the actual property name for our nodes, that's something that's just going to be called name. And in our case, we want to call it country. So we have a country label for our nodes, and the property is going to be named country. Okay? So that's what we want to do. And now if we look real quick, just to prove you I'm not cheating at all. So if I try to look for countries, I should not have anything. Yeah, I have 0 countries so far. All right, so I've done this. I will try maybe to make it, or maybe I can move that so it's not, yeah. Okay, slightly better. Or even better, we'll do like this. Oh, come back. What? Come back here. Yes. So it's a bit more readable for everyone. Okay, so I have header, so that's the name in the CSV. The data type, I think by default it's going to be string anyway. And name, which will be the property name in my case. So let's do that. You know the drill now. Update SQL first. Still the same file, still the same connection metadata. All right, and what do we see? Well, in our case, actually, I know something, but yeah, that's interesting. What we're going to do is we're going to run this. So there is this magic $1 that you don't really know about. Basically, the $1 will be a batch of rows, of CSV rows, and we're going to create country nodes, and the columns of those rows will be properties. So that's a shortened Cypher syntax. You can look it up in the Cypher manual if that feels a bit weird looking. But that's basically the change set I'm interested in. And there is no other change set before that because we've run all of them before. And all right, so that seems to run successfully, which is not, again, as you've seen before, always a guarantee that it's going to work out when I actually run update, but let's see. Last time I said I was pretty confident. I screwed up, so I'm not going to say that again. Let's update now. And I'm going to get some water as well. All right. And so now we have a new change set that has run. The 4 one before are still there. And if we look at history, we should see like 2 groups. The first execution with the 4 change set. And yeah, I'm going to put it in full screen, full width. And the new one that I just run now, which has load country data. So that's our new change set. A new kid on the block. And let's just see now in my database, I should have 98 countries, which I believe is correct. Because we do create, by the way, we don't even do merge. Yes, so that's 91 minus 1 for the header line. So yes, as far as my math is concerned, that checks out. All right, so that was one example, and that's exercise 2. That's one example of something that is not a Cypher query. Again, that's a change that is part of a change set. And what we could do, we could add more things, right? We could add Neo4j Cypher and do more things in there if we wanted. In that case, we already run the change set, so we're not going to do that. But you can have multiple changes again, right, per change set, and they don't have to be old Cypher queries. So now, let's start something a little more complicated. So now what we're going to do first, and this one I'm just going to copy because we've done that before. We're first going to create a constraint on country names, which is something that does not exist yet, right? That does not exist yet. Or actually, you're going to be consistent, and we're just going to call it country here. So we create country name. So we make sure that the country properties of nodes with the country label are strings. So we're going to do that. And I'm going to get a bit ahead. I'm not going to check and then run and check the history. Let's continue building. So what we want to do now is let's look at our data set a little bit. So if I scroll again, no, I don't have it anymore. Okay, that's fine. If I find movies, cannot type, sorry. Let's take 5 of them. I'm just going to pick this one and move it around a bit. Yes, you can see there is this countries property. And so what we want to do, that will take a couple of steps, is to extract those into proper nodes. So we have the nodes already, right? But they are not connected. And we don't want this information to live in the movie nodes anymore. So what we're going to do is first use, so if you look at our documentation, what we want to do is called, so if you go to neo4j.com/labs/liquibase/docs, and then you go to features, reference features, you will see, and I will make it full screen, you will see, so there is load data explained as well. It's not, it's something that core provides, but there are some more explanation about how the extension handles it. And then there is something called node property extraction. And you have examples in all languages, right? So basically what we want to do is to extract properties from nodes and link them to the nodes they were extracted from. So in our case, there are arrays. So we'll have an array property that is extracted. And then we do a second step to transform these arrays into individual nodes, right? That's why there are several steps involved. So first, let's try this extract property example, but applied to our data set. So as usual, now we create a change set. And what we're going to do is we're going to basically extract countries from movies. That's what we want to do. So that the property is called countries. We still need an author. And what we want to do now is basically, so this one is, it's a graph refactoring, so that's not part of core. That's definitely in the Neo4j namespace. And what we want to do is extract property. So my little one is crying next to in the other room. Extract property, and then you will have to describe, so what property are you interested in? So, oops, if I cannot type, so that's going to be great. I'm interested in the countries, right? I think that's called countries. Yes, it's called countries. And then I want, from which pattern, so from which nodes pattern. So in my case, I want, so it's a fragment, right? It's not a full-blown Cypher query, it's just a pattern part of the query. So in my case, I'm interested in, and I'm going to give it a variable name because I need that variable, right? It could be something more complex with several variables. So yeah, I need at least one variable. So I'm interested in movie nodes, but there is a catch again that I'm not going to make you run through, is if you look at movies without countries, there are actually a few of them. So we don't want those because we're not going to be able to extract anything in that case. If we count them, there are 24 movies. So even less that plotless movies, we have countries less movies, but we're not interested in those. So in that case, we just add this safeguard where countries is not null. We're interested in movies that have a countries property. So we are going to extract that. Okay, all good. And we're going to merge, right? Because we just loaded data before. We don't want to recreate countries all the time. So we're just going to merge that. We don't want to create duplicates. There is no point. So by default, it creates those thing for us, but we are going to merge. So actually, my bad, it's not, mixing things up. And so you need to say that the nodes you're interested in part of your patterns, you need to give the variable. So in that case, those are the movie nodes. So that's the source part. I'm interested in movies without countries. But then I need to know, okay, what is the destination? So first, I'm gonna just close that up. Sorry, I'm getting confused with my keyboard shortcuts. Trying to reformat it a little bit. And so what is the destination? And so now I want to say, okay, I have my source. Now I'm gonna extract this property to these nodes. These nodes, so the label is gonna be country. The property is gonna be country as well. Let's be consistent. And I want to merge them. So that's where the merge is in, that was my mistake. Merge is actually in the destination, because in the source we just extract stuff. We don't create nodes or anything like that. I'm not sure it's complaining about this weird red thing, but okay. So that's the first part, really. And then the second part, we want those countries to be linked to the movies they were extracted from. And so you have another, it's a bit like Inception. We just go deeper and deeper. We want them to be linked from source. So those country movies need to be linked from source. And the relationship type that is this link, right, will be, in our case, let's keep it simple, in country. And we want a direction from the source, right? So it's going to be going out of the source to the country. So the movie is going to be in country, and then the destination is country. So the end node will be country. So in that case, direction is outgoing. Okay, so that's quite much more complex than our usual Cypher query, right? So what we're doing, as a recap, we want to extract the countries property from the nodes matching this pattern and that are designated with this variable name. So in that case, movie nodes with the countries property defined. And we want to extract those to nodes with label country, and the property is not going to be named countries, but country. Or actually, we could even say countries for now, because that's still an array. So yeah, let's keep it simple. We'll merge them, right? We're not going to create them, and then we'll link them together. And so that's, that's pretty big change. So let's be a bit careful. And let's do, oops, Jesus, I cannot type. Come on. Update, yes, but update SQL first. Let's not get ahead of ourselves too much. Ooh, there is a bunch of things going on here. So we have this type constraint that we've put here, so that's all good. That's a thing we didn't run before. It inserts it in the changelog history, and then we should see a little more. Sometimes it's not completely clear, but it's right there. So you can see it generates Cypher query with some weird syntax, just to make sure we don't have collisions, but we're doing the pattern you specified, and then because it's merged, we'll merge the country, and we'll create a relationship to that to those movies. That's what is being translated for you. So that's also a good way to check, right? When you have a complex change like this, like what the heck does it mean? You can try update SQL and refine and go back to your changelog to make sure that it actually does what you think it does. And obviously, if the documentation is not clear enough, that's on us. So ping us and we improve it. But that's also a way to make sure you understand what's going on. And then same thing, we just insert it into the history, delete the log, and go on. So all right, let's just do that. So let's just run it now. So we have countries so far. Like if we, I don't know, let's just see how they look like. We have 98 countries so far, and they have a country property, so single value. So now when I run this, All right, so we added, two new change sets, a constraint and this extraction. And so if we look again at the, I don't know, let's match movies maybe. Let's see some movies with countries basically. That's what's supposed to happen with this extraction. In country, if I can type. So let's see, and I don't know, let's take again a limited number. So if you do that, yeah, maybe not the best idea because there are a few more things going on, but if I can spot it real quick, yeah, actually let me change the query just to return the country as well, so I don't have to unfold everything. Yeah, so you can see here, USA. So for now, it's still countries, right? Because I took the property as an array and extracted as is. But all those 5 films from my sample, which is not too surprising because USA is like a big movie producer, all those 5 films are in this country. Okay, so that's my first step, but that's not exactly what I want. I want to come back to countries with a single name like this. My 98 movies with a name. Like if I redo so is this with a country property singular, not plural. So now the second step, and it's much more Cypher related. I could put it in the same change set. I decided to split it up just because I like to be more granular in the changes I do, but it's really up to you where you place the cursor. This time I want to go over those new countries with the array property, and I want basically to explode that array in a way and create individual nodes instead. So let's do that. And so we'll need, as usual, a new change set. So in that case, we'll say, explode. And explode is not the best name, but I started my career with PHP, and I think explode was one of the PHP API to flatten an array. All right, so let's do that. So I've got my change set, and here we're just going to do regular Cypher, but we're going to write 2 Cypher queries because you could do, actually, spoiler alert, if you really want to, you can try to do it in one query. It's entirely possible. But in that case, you know what? It's actually easy enough to do it in 2. It's actually a bit simpler to write and probably simpler to read. So in that case, I'm just going to do that. So what do we want? We want to match, and I'm going to do it right away, right? We want to match countries which have a countries property. Remember, we extracted the countries property over there. So let me scroll up a bit. And we know that the other countries you created before with load data, they don't have this property, right? So that's why I'm not adding extra check. You could, in theory, check where countries is defined and country singular is not, but that's not necessary in that case. So we want those countries. We can actually do the fancy syntax, right? We have quantified pattern path and whatnot, and you can do actually that just for fun because it's it's also possible. What we're going to do is basically iterate over those countries. And for each, what do we want to do? Well, we want let's say a row country, because actually here I'm going to go a bit fast, but you will see that some of the names have spaces before them. So we're going to transform that a little bit. Otherwise, we'll have duplicates because you will have, for instance, USA and another country called space USA, and we are not really interested in having those duplicates. So yes, let's go over them. So that's standard Cypher, right? So what first I'm going to do, I'm going to clean up those values. So now that's the country I'm interested in, that's the country value I'm interested in. I also not interested in duplicates because there can be many countries in theory, but actually that should not be the case, but we never know because of the trimming. So we're also gonna do distinct just in case. Maybe we had space USA and USA, so we just want to make sure now after the trimming we only have a single USA, a single France, etc. And we're going to create, first we're going to create those country with that. So with country property equal country. So that's actually we're going to merge because they might exist from the load data from before. So that's the first step, right? And I'm gonna go ahead a bit. I could test this, update SQL, update, checking history and whatnot. And now, okay, I have those countries. And what do I want to do? Well, I want to link those countries to the movie, the initial countries here where I'm matched from. So I'm gonna start again with the same beginning. And what I'm gonna do now, I'm gonna match all the countries that were in the array of the original country. So I want this new country. And let's do the fancy syntax again. So new country, so the country value, the singular country value should be in there, in the c.countries. So that way, new and c are related because the country singular name is inside the array. So that's how they correlate to each other. And now that I have done that, I can actually, make sure to match the movie. So I'm gonna invert it a little bit because I'm interested in this. Because of the extraction, it looks like this. I have a movie. Oh, and yeah, welcome to XML. That's the only annoying part when you've got relationships. So it's less than, you need to escape that. So you might want to switch to JSON just for this. You want movies there. And what I'm going to do instead is do this. So first, where new country is defined. So is not no as well. And here I'm going to add the correlation between the two, where new country in C countries. So in theory, that should be enough, but just being extra explicit. I should just need the in clause. I don't really need the is not no, but that's probably fine. So now I have the new movies that were in the array of country names of the old movies, and those old movies are related to movies. And what do I do all of this? Well, now I want to link, and I'm being careful, I'm using merge. Theoretically, I might not really need to do that. I'm basically gonna create the missing link between those two, and we're in XML, so you need to escape this. Or you can actually write, this weird syntax that I always forget, see data, whatever. So I think something like that. That's another option. Yeah, I never remember how to do it, so that's why I rather escape. But again, you can also switch to JSON or YAML, and you won't have this escaping issue. So movie is in country, and now finally, now that we've linked the new extracted countries to the movies, then we can remove the old one. And once you've done that, then you should be good. You should have all your countries with singular names, and they are linked back to the movie where the movie was produced. Movie might be linked to several countries because they can take place in different countries or produced by different countries, etc., etc. So just to recap, we've extracted those nodes. We've run that, right? We've taken the countries property, and we created country nodes with the countries property because it's an array. We merge them and we link them to countries. Then what we do, we go over those new nodes, those new country nodes with the countries array property. We iterate over it and create country with singular names. So that's our first query here. And then the second one is, okay, let's go over those new countries. And please find the corresponding old country with the countries array, where this new name is contained in, and find the movies they are linked to. Then please create a relationship between this new singular named country and the movie, and detach, delete, so remove the old country and its relationships at once. And at that point, once I'm done running this, I should have finally the result I wanted, which is movies in countries where the countries have a singular name, and movies should not have, like it's already the case because we extracted the property, movies should not have any countries property or country information in the nodes at all. And in the future, by the way, we're going to save you all of this. I'm already planning to implement support for arrays, so you can actually do more or less what's going on there. So that's a future improvement that we're going to do that is not there yet. So let me just check Q&A a bit. All right, so far so good. So let's now run update SQL. I mean, we just have two new Cypher queries, so we should see them in the output. And we actually do. We see this new explode and deduplicate. So let's read the last time just to make sure I didn't screw up. So we have a country which has a countries property because they were extracted like that. I believe that's the case, right? Let's double check. We never know. It's getting late and it's hard. It's hard to not make mistakes. So where C countries is not null, and how many are there? Count C and no need for limit. Okay, so we have 832 extracted, right? Extracted straight away from the 9,000 movies, because there are a lot of movies with only USA as a value. So that's why, because we merge, we don't have exactly a one-to-one mapping here. So what we're doing is matching those countries, creating singular named country, and then then looking at those new countries we match with the singular country property, correlating them, making sure we find the corresponding countries node, and finding the movie there. And then we create the relationship between the singular name country and the movie, and we detach the old country. So at that point, yeah, that looks correct to me. Let's see. Let's actually run that. I will drink some water as well so I can speak until the end. Nice. Okay, so I've got a slight Cypher mistake that I didn't catch. So let's see, variable name not defined. Where did I put name? Oh yeah, we didn't tick name, of course, it's country. Yeah. So that failed right away, so that's a good scenario. I should be able to just rerun that. Okay. So rows affected, it affected a bunch of rows, so that's always good to see. And now let's see. I should have now 0 country with a plural property like that. I should have 0. Yes. I should have not 832, because that's too much. Remember, when we loaded data for 98 countries, which is the number of countries in the data set. So we should roughly have the same number. So let's see. We have 98. That's quite reassuring. Okay, so we have extracted those nodes. And now let's see, let's just match like this. We should see some movies in the data set. No, I don't mean watch movies. I mean, you can watch movies, but please do it at the workshop. Sorry, silly jokes that only kind of work in French. Anyway, so yeah, let's watch movies. Let's watch those movies in the result set. Is not null. I don't care. And we should see. Let's return the movies, the country, CM, and limit 20. Country in country. Why did I fail? Movie in country. Nothing really. Okay, so let's debug. That's the joy of running towards the end of the workshop. So I have some countries. Let's pick maybe USA. Country is USA. Yes, this one should have quite a few movies. And what is this? Okay, that's interesting. So I kind of messed up my database, I guess. Again, So let's live troubleshoot this. That's what happens. So we have recap. We have country with country's property. We merge them, and we have movie. We have an in-country relationship with those country. Then we go over this country's property. We iterate over the country names, and we merge the country. That's all good. Then what do? We make sure that we have those new country thing that are defined. Then the old country with the country's property should be defined, and the new country name should be in C countries. So far, so good. That should be in countries. The movie should be in that country. Then we should merge. Oh, I guess. Did I invert? No, movie. Ah, it's M, of course. Oh, of course it's M. Nice. So okay, so that's easy to fix actually. So let's actually do it the proper way. Let's say it's a production. So what I did is merge a label-less node. So the actual, I could do that, right? But that's not really great. That's not planned. Let's improvise an actual fix. Let's say you're in production, you just messed up your change set. So hopefully not, but you have pre-prod environments and whatnot. A fix up in country. Oh, except that's gonna be fun because I lost the information. Yeah, so no, I'm a bit, yeah. Oopsie. So see, I was not being careful enough. I didn't test it enough. That should be M and not movies, but because I deleted the link between the countries, etc. So yeah, again, the Joker card, you didn't see anything. I'm using, so let me see, CD that. Joker card, let's go. The joy of being live. 2 mistakes so far. That could have gone worse. So yes, make sure, even though you have dry run, etc., make sure to test in an environment before production. All right, my database is reset. I'm just gonna rerun this. Let's be confident. Run everything at once. Boom. So all the change sets. Yes, and now hopefully I will get what I want. So I have USA, and I've got a gazillion countries. Here we go. Yeah, maybe US. Let's take France, for instance. Fewer movies. Yeah, still. What kind of movie? What kind of countries did we have? Let's say, I don't know, Japan, just to have a less messy output. Yeah, no, still Peru. But yeah, it works. I'm just playing around. But yeah, we have movies in countries. So yeah, if you don't mess up the query like I did, you should have what we wanted, which is extracting with the extract property refactoring, and then splitting the array into individual properties in different nodes. And because it's error prone, as you can see, we will actually integrate likely a new option, something like explode array true. That's not available yet, but that's something, I was already convinced I need to do this. Now that I failed live, probably a bigger motivation even to do it. I'm not sure about the name, obviously, but by default it will be false because it will remain to be backward compatible, but we will probably do something like this. So this becomes almost unnecessary, except you will have the trim problem because some names have space in it, and that's not really something we want to. That's more of a data problem than an Liquibase problem. But yes, that would basically simplify a lot of this. All right, and the last thing I wanted to show today is so far what we've been doing is very common with Liquibase. You add change sets, you test them, dry run them. Sometimes it goes wrong, as you can see, and you either, lucky enough, you add a new change set to correct it, or you reset your local database. But now we'll do something a bit different. We'll try to go back in time. So we'll try to go back to where, so far we've been going, I was about to say onwards or upwards. I'm confused about directions now. Now we're going backwards. But for that to happen, we need to help Liquibase a little bit. And we've seen Cypher queries and changes. And what you can do as part of change sets, and you can actually add safely that to existing change sets. That's not going to change their checksum, so it's not going to be considered a modification. So what we're going to do now is we're going to add rollback queries. I mean, rollback can be any change, actually. So you could have any change as a rollback. But now, and for sake of time, I'm just going to use my cheat sheet, except I didn't use exactly the same property name, but I will try to fix that. So let's start maybe with the change set before, because it's a bit easier. We extracted properties, right? We extracted country. So remember, at the end of this, before the other change set ran, we had new country nodes with the countries properties that come from movies, all right? So what we're going to do now, we'll do the reverse operation. And I'm going to do basically this. I'm going to specify a rollback. It could be many Cypher queries, many different changes, something else. So in that case, it's going to be a simple Cypher query. And what we're going to do, so you can say I change, so it's actually not country.names, it's going to be country.countries. So remember, you need to think about what is the output of the change set, regardless of what happened after, right? What happened before is relevant, what happened after is not. So here I'm saying, okay, match the countries that are linked to movies, put back the country's property back to movies, reading from the country's property of country, and then delete the country nodes because we don't want any at that point. We want a basic, reverse of extract. So that's it. So now that's the opposite operation of this one. Maybe we should have a change which is, I don't know what's the contrary of extract. I'm not an English native, but yeah, the opposite of extract could be, yeah, I don't know, reverse extract or something. That's definitely possible. It's not available yet, but for now, at least you have Cypher. So that's the first step. And now we're going to do this one, basically the opposite of what these two are doing. And again, we'll keep it simple. We'll basically do the opposite. And we'll do the opposite in two queries. You could potentially do it in one query if you fancy it. So you can see rollback, by the way, is in the Liquibase namespace. And we're gonna do that. So obviously I need to adapt a bit because the property names have changed. So it's not country name, it's country, and names, why not? But let's be consistent. It's named countries. So when I roll back this, I should be in the exact same state as if I had never run this. And so I should have country with a country's property, which is an array. The order might not be exactly the same as before, but it's good enough for me. And we have the trim thing also, which is a destructive operation. So I will have trim names. I'm not going to have the original names with spaces back. There is no way to resurrect this information here, but that's a good enough compromise in that context. And so yeah, we're doing exercise 4, but we don't need to comment. So in that case, what I'm doing is I'm taking back those singular name countries to a country that has a country's property, and then I also link them to the movie, those countries, those singular name countries were linked to, and then I go over this country with singular names and delete them. And here it's country. So I believe that's correct, and for the sake of time, I'm not gonna do dry run and the whole dance. I'm just gonna be doing, you only live once, right? So I'm just gonna try that live right away. So that should basically reverse everything. And so what I'm gonna do now, so far we've been using update, right? Now what I'm gonna do is gonna use another command. And GT, someone mentioned GT, yeah, movie in country, yes, so from movie to country, it's this direction, and in that case, it's country movie, so it's another, the direction is reversed. So yes, that's why you have greater than for GT, and less than, which is basically this symbol here, versus this symbol there. That's XML escaping, right? That's because I'm using XML. You could wrap the changes in the what's called CData if you're really curious. If you don't want to escape, you can use CData to wrap your content. So this one. So that should be basically this, and you don't have to escape anymore. That's another way to deal with it. You could do this. I always forget the syntax, so I'm just shamelessly copy pasting it, but you can do this basically. and you don't have to. So you can do that again. That's another option, basically. That's equivalent. CData means don't try to interpret this as XML. But for now, I'm just escaping, so it's really up to you what you prefer. So yeah, greater than and less than. All right, so those are my two Cypher queries. And now what we're gonna do is we're gonna roll back. So you have a bunch, if you run Liquibase command, you have a few rollback commands, and we're gonna use the simplest one here, which is rollback count. And we're just gonna tell him, okay, you have run this list of in order of change sets, and I'm just gonna roll back the last one, the last two, the last three. So we're gonna do two invocation in a row, roll back the last one and then the one before that, but into invocations. So this one I will do rollback count. Rollback count 1. And so first, let's have a look at the history first, just to remember what we're starting from. So we have, because I reset my database and messed up, we have all of them in a single execution. That's the last one. That's explode and the duplicate country codes. So now I'm gonna do rollback count. And what it's gonna do, it's gonna, it sees the history and okay. So the last one, I'm gonna go back, I'm gonna cancel it by going through the rollback instructions here. So hopefully that will work. And if not, I'm not sure I will have enough time to fix it, but okay. So it's telling me, okay, I'll roll back that one, as if it never ran. So if you run history again, well, it's not there anymore. And in theory, it's as if we had never run it. So as if we were basically at this change set here, which means we should have the same as a result of extractions. So if I count movies with a singular name property, there should be none. Where C country is not null, so where it's defined, if I try to count them, I should have 0 now because they don't exist anymore. I rolled it back. So 0. However, if I count countries, the array thing, yeah, I have all of them. Yeah, because I created them. I didn't merge them. Yeah, so that's the only difference. I should probably have put merge here. But yeah, that's the only difference. That's a small mistake I did. But in that case, yeah, you really want merge, actually, not create, to be exactly the same as the other one. But anyway, we're going to fix it with this. So that's just going to work all the same because we're going to get rid now. If we roll back again, so we're running the same command as before. So remember, now our last change set is extract countries, and we're going to roll back that one. And it should say, well, yeah, I'm rolling back extract countries. If we look at the history now, we're basically back to make countries, names typed. So we're back to this one. So in theory, we don't even have country nodes anymore, basically. You don't even have countries anymore because I deleted all of them and the countries property is back in movies. So now if I even count that, I should have 0. Yeah. And if I match a sample of movie, chances are I will find my movies with countries property as before. And you can see countries is back. So most of them have only USA, but some of them are more than that. But so we are back to where we were. So again, small mistake here, it should have been merge, but apart from, in that case, it's without consequence because I rolled back the 2 of them, and the second rollback basically delete every country. But yeah, to be exactly symmetrical, it should have been merged. But yeah, what never 2 without 3. So I did 3 mistakes tonight while live demoing this. But so yeah, that's also a way to, sometimes it's useful, but keep in mind, of course, it rolls back only things it knows about, right? If you have, for some reason, some other data that have been inserted by some other means, that data is going to be still there, right? It's only affected what you define in rollback. And some changes, that's not the case so much with the extension changes, but some changes have an automatic rollback query, right? So you don't always have to write an explicit rollback, but I think it's a good practice. So you can see In the rare case you need to roll back, you can see the opposite operation, or almost opposite, because again, for an instance here, you can't really do the opposite of trim, because that's an information loss operation, right? You cannot really put back the spaces unless you track where they are, etc. But that's a small information loss that is deemed acceptable in this context. And yes, that's mostly, yeah, I had another example. I'm just gonna show the syntax to you. I'm not gonna run it because we're a bit out of time, but there is another thing I didn't mention that is supported by Liquibase core and in general, and Neo4j extension in particular, which is preconditions. So by default, your Cypher, your change set, sorry, will always run. But you can also put preconditions and react and have some specific error handling. So for instance, we could imagine, so I'm just gonna copy paste here, I'm gonna cheat. You could imagine something like, hey, you know what? Here I assume APOC is there, but maybe APOC is not installed. So what you could do is, instead of failing, I mean, you have several policy, right? You can say halt right away, like if APOC is not found, so if this procedure is not found, here I expect exactly one procedure called APOC schema insert, and I return the count. I expect it's one. And if that's not the case, you could say, well, you know what? I'm going to continue. I'm just going to ignore this change set. I'm not going to run it, but I'm going to continue the rest of the migration. Here, for keep it simple, I decide to halt, which is more or less the same as not writing the precondition, because if APOC is not installed, it's going to fail. But it's a bit more explicit. And you can have also like DBMS, I think its name, Neo4j, for instance. So by default, it's going to be end. So for instance, if you're using your changelog for different databases, you want to make sure that Cypher ones are only running for Neo4j, and the other ones are running for the relational database of your choice. So you can add these kind of things. What else? You have also Neo4j edition. Maybe you want to run. Maybe you have a mix of Neo4j community edition and enterprise. So you want to make sure that those are also checked. It's all in the documentation. So that's another way also to sometimes circumvent some change sets if they don't apply to all of your targets. So that's a useful way. So if you look at preconditions, the version check that I just you have this Neo4j version, Neo4j edition, and if whether it's enterprise or not. So enterprise false is community, and enterprise true is enterprise edition. And the Cypher check I just showed you, which is the most flexible, you just count something and it will compare the result. We're planning to add more, like this little check here could just be procedure exists, for instance. So that's going to be something we're going to do. Function exists, etc., etc. So that's really what I wanted to show. I think I have 2 minutes left, so let's be aware of time. And let's wrap this up. So thanks, everyone. If it went too fast, as Alexander said, you will be able to replay it and also learn about my mistakes. Otherwise, it's an open source project, and in open source, for better or worse, popularity is sometimes measured in terms of stars. So if you have a GitHub account and you want to start the repository, we would be super grateful. There is a Neo4j webinar on March 28th, and of course, there is always Graph Academy to learn more about Cypher and all the exciting things Neo4j has to offer. So over to you, Alex.
Cool. Thank you very much, Florent. That was great. Super cool demo, and I think hands-on guiding. If you like you said, if some things were a little bit too quick, something was a little bit too fast for you, then obviously this will be recorded, or it was recorded, and we will share the link to you in a bit, so you can check it out, as well as the slides. If you think, oh, this is this was a little bit over my head, then we have more workshops as part of this series. There was one as an intro session last week. We continue on Thursday with a RAG workshop. On next week, we continue with a geospatial. There is more content on our forum, on our GitHub pages, as well as for Liquibase, as for Neo4j, as well as on our Discord for server. So there's more resources available. We do regular live streams on YouTube and LinkedIn. So if this is something you're interested in, join us there. Follow our accounts so you get the latest information from there. And yeah, I think that's a wrap for today. If there are any questions later on, use the forum, use Discord for that. I think that's best. I mean, you can obviously also use you get the link, and then you can comment on the link as well. And I think that's it. Thank you very much again, Flora. It was really great. I had a good time today, and yeah, thank you all for watching. Thank you for your time. And I hope to see you around in one of these upcoming workshops or a live stream or on the community forum somewhere else.
Thank you very much.
Thank you all. Take care. Bye bye.